We'll be covering solving quadratic equations by factoring, completing the square, and by using the quadratic formula. So let's review solving an equation by factoring. So the first thing that you need to do is set the equation equal to 0. Once you set the equation equal to 0, then you follow the steps of factoring. The first step in all factoring problems is to remove the greatest common factor. So in this first example, 8x squared minus 3x equals 0, we can remove the greatest common factor, which is x. So when we remove the x, we divide x out of 8x squared and minus 3x, and that would give us 8x minus 3. So we have our two factors, x and the quantity 8x minus 3. So to finish solving, we set each factor to 0 and solve. So one of our solutions is x equals 0. The other we find by solving 8x minus 3 equals 0. So our other solution is x equals 3/8. Now let's review how to factor x squared plus 6x minus 72. Remember that anytime our leading coefficient is 1, in other words, here we just have 1x squared, we can use the shortcut in factoring. So the shortcut in factoring is all we have to do is determine what two numbers multiply to give us a negative 72 and add to give us a positive 6. So the two values that multiply to give us a negative 72 and add to a positive 6 would be a positive 12 and a negative 6. Positive 12 minus 6 is positive 6. Positive 12 times negative 6 gives us our negative 72. So then we finish this problem by setting each factor to 0. So we set x plus 12 equal to 0 and solve. And we set x minus 6 equal to 0 and solve. So our two solutions would be negative 12 and positive 6. Our next problem, we have 3x squared minus 26x equals 9. So the first thing that we need to do is set the equation equal to 0. So we need to move the 9 from the right-hand side to the left-hand side by taking the opposite. Once we have the equation set to 0, now we factor. So in this case, we look to see if anything divides evenly into 3x squared, negative 26x, and negative 9, and there's nothing that does. We can't use the shortcut because our leading coefficient is 3, so we're going to use that AC method of factoring. So what we do first is multiply our leading coefficient, which is 3, times our constant, in this case, negative 9, and that gives us a negative 27. So we're looking for the factors of negative 27 that add to a negative 26. So we know that 1 times negative 27 equals negative 27, and 1 plus negative 27 equals negative 26, which is our middle term. So now what we do is rewrite our expression so the 3x squared stays the same, and we use the positive 1 and negative 27 to rewrite our middle term. The minus 9 stays the same, as does the 3x squared. Now again, for a review, we group the first two terms together and the last two terms together, and we remove the greatest common factor. So if 3x squared and positive 1x, the greatest common factor is x. So when we remove the x, that leaves us 3x plus 1. For the second group, the greatest common factor is 9. And when we have a minus in front of our third term, we're going to factor out that negative. So it's going to be a negative 9. So we divide negative 27x by negative 9, and that gives us positive 3x. And negative 9 divided by negative 9 is positive 1. And recall that we want these two factors to be identical. So our last step in the factoring process is the 3x plus 1 is our greatest common factor, so we'll factor that out. And when we factor out the 3x plus 1s, that would leave us with x minus 9. Now we're going to set each factor to 0 and solve. So we set 3x plus 1 equals 0 and x minus 9 equals 0. And now we're going to solve for x. So one of our solutions is negative 1/3, and the other solution is 9. So again, you'll be using the AC method, also called the reverse FOIL method, or some people use trial and error, whatever you're comfortable with, but this is a review topic. Okay, the next concept is brand new. We're going to go through a process called completing the square. And for this class, our leading coefficient is going to be a 1. So we're only going to deal with our leading coefficient being 1. So we'll deal with 1x squared minus 10x minus 5. So the process is this. The first thing that we do is we move the constant on the other side of the equal sign so that terms that have x are isolated. So we have x squared minus 10x equals positive 5, because when we move a negative 5 from the left-hand side to the right, it changes signs. So that's step number 1. Step number 2, we'll take half the middle term and square it. So half of negative 10 is negative 5. And when we multiply negative 5 times itself, we get positive 25. So what we're going to do is add that to both sides. Okay, the reason we did that is we've created a perfect square trinomial. What that means is this x squared minus 10x plus 25 comes about from multiplying a factor times itself. And so that factor would be x minus 5 squared. So in order to factor the perfect square trinomial, we have x, and then we'll take half the middle term, and half of negative 10 is negative 5, and that would equal 30. Our next step is to use the square root property. So the square root property says whenever we have a value squared or a quantity squared, if we want to get rid of the squared, we take the square root of both sides. Now, when we're taking the square root, we're going to have two solutions, the positive and the negative solution. So on the left-hand side, the square root of x minus 5 quantity squared, remember, the purpose of that was to eliminate the square. So all we'll have is x minus 5. On the right-hand side, we have two solutions, positive and negative square root of 30. We see if we can break down the square root of 30, which we cannot in this case. There are no perfect square factors of 30. So what we're going to do is add 5 to both sides. When we add 5 to both sides, we get our two solutions. So x would equal 5 plus or minus the square root of 30. So our two solutions, 5 plus the square root of 30, and our second, 5 minus the square root of 30. So let's look at our next example. Again, we're going to do completing the square. So our first step is to isolate. So we have x squared plus 16x equals negative 47. So we're going to create a perfect square trinomial. In order to do that, we take half the middle term. So half of positive 16 is positive 8, and we square it. So when we square 8, we get 64. What we do to one side, we do to the other side as well. Now again, we've created a perfect square trinomial, and it's going to be x, and then half the middle term, half of positive 16 is positive 8, equals negative 47 plus 64 is 17. Next, we're going to use the square root principle. So we're going to take the square root of both sides, keeping in mind we have two solutions, the positive and the negative. So when we take the square root of the quantity x plus 8 squared, remember that just eliminates the squared. That's the purpose of doing that. And that gives us x plus 8 equals positive or negative square root of 17. At this point, we would simplify the square root of 17 if possible, but it can't be simplified. So the last step, since we're solving for x, we isolate, and our answers would be x equals negative 8 plus or minus the square root of 17. Next, again, review solving a quadratic using the quadratic formula. So the quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The quadratic formula was made by completing the square of the standard form of a quadratic equation, which is ax squared plus bx plus c equals 0. Okay, so what we're going to do first is make sure that our quadratic equation is set equal to 0 and is in descending order, which this one is. The next thing we're going to do is to identify the a, b, and c so that we can plug it into the formula. So in this case, the value in front of x squared is 3. So a would be 3. The value in front of x is positive 3. So b would be positive 3. And our constant would be 8. So now we plug these into our formula. So the first thing we do is the opposite of b. So since b is 3, the opposite would be negative 3. We have two solutions, plus or minus the square root of b squared. So when we square 3, we get 9. Minus 4 times a, which is 3, times c, which is 8, all over 2 times a, which is 3. Okay, so now let's simplify. Negative 3 plus or minus the square root of 9. And we have negative 4 times 3, which is negative 12, times positive 8 is negative 96. And that's all over 2 times 3, which is 6. So now we're going to take 9 minus 96, and that gives us a negative 87. So we'd have negative 3 plus or minus the square root of negative 87 all over 6. Now keep in mind, whenever we're dealing with a set of complex numbers, when we have a negative underneath the radical sign, that's the same thing as having the square root of negative 1 as one of the factors. And remember, that equals I. So to simplify, we have negative 3 plus or minus I square roots of 87 over 6. So 87 cannot be broken down any further. And you can't simplify 3 and 6 because 6 belongs to both the negative 3 and to the I square roots of 87. So since nothing divides into negative 3i and 6, this would be your final answer. The negative 3 plus or minus I square roots of 87 over 6. Let's do one more. So here we have 4x squared equals negative 10x minus 2. So the first thing that we're going to do is set it to 0. So we have 4x squared. We're going to move the negative 10x from the right to the left, so we change the sign when we do that. And we're going to move the negative 2 from the right-hand side to the left, so we change the sign of that as well. Because remember, when we're using the quadratic formula, we set the quadratic equation equal to 0. Now we're going to identify our a, b, and c. So a would be 4, b would be 10, and c would be positive 2. So now we're going to plug that into our quadratic formula. So we start with the opposite of b. So the opposite of 10 is negative 10, plus or minus the square root of b squared. So when I squared 10, 10 times 10 is 100, minus 4 times a, which is 4, times c, which is 2, all over 2 times a, and 2 times a being 2 times 4 in this case. So now we have negative 10 plus or minus the square root of 100. And now we multiply negative 4 times 4, which is negative 16, times 2 is negative 32. And that's all over 8. So we have negative 10 plus or minus the square root of 68 over 8. The square root of 68 can break down. That would be the square root of 4 times the square root of 17, which would be 2 square roots of 17. So now we would have negative 10 plus or minus 2 square roots of 17 over 8. Now we look to see if anything can divide into negative 10, 2, and 8. Since 2 does, we divide 2 out of each one of these. So our final answer would be negative 5 plus or minus, you don't need to show the 1, so we can do it as the square root of 17 all over 4.